it as we continue with the meeting. So after this, we'll also perform the foundation design in prota detailed and export the details to AutoCAD for printing. Then from ETABS, we'll export the foundation results to SAFE software. And then this CSI SAFE will now perform the design and detailing of the foundation. Then we'll now we'll export this one to AutoCAD for printing purposes. So allow me open my AutoCAD software because we are going to rely on it. As I said in this platform, we said we are going to use AutoCAD. We are also going to use the other software is ProtaStructure and ETABS. So for this one, let me just open AutoCAD. You can actually use any version of AutoCAD, but for me, I'm going to use the latest version of the software, that is AutoCAD 24. ETABS, I'm going to use the current version 21. Then Prota, okay, it's good for us. I could have used AutoCAD ETABS, ProtaStructure version 2024, but because most of us are using 21, we are just going to, I will install 21, and I think we can use that one. Now, I'm not going to write down most of the things, but because we are recording the session, I think it will be good for us to follow the video that I will actually upload, and it will be nice. And apart from that, be noting down some things that will be new to us. So after opening AutoCAD software, the first thing is just to open a new model. Then after opening the new model, you have to save it. I'll just press Ctrl S. Of course, you can save the model from here. You can just come here to the AutoCAD icon. Then you can press save or save as. But for this one, I'm just going to press Ctrl S. Then I'll save this one to desktop. Let me just create a new folder here. Name this one online session, something like that. Then inside this folder online session, I'll now give this one structural layout, or just layout. Layout is just okay. You give it a name, then save. So we have the structural layout that we are going to create here. The next thing is now to set the units. We are just trying to set the working environment inside within AutoCAD, because this is what we are going to use to now export to ETABS and ProtaStructure. Now, to do that, we are going to first of all set the units, the working units that we're going to use. So to do that, you just type units and select these units. Then in Africa, most of the African countries, we've been using the metric, the SI units, the international units. Remember, we have the American units, the Imperial, and the SI. So we are going to use the SI units. And the precision of my length, I'm going to use 0. Then the angle, of course, we can use 0, but we are not going to use this one, but we can just use 0 and then okay. Then after setting the units, the next task is now to figure out the layers that we are going to use as we create the structural layout. So for this, I'm going to share something. Let me just open this because it will actually help us. I was trying to prepare something, but yeah, I'll just share with you this. So in the structural, in this session, we are going to use AutoCAD, of course, version 24, then ProtaStructure version 21. Then we are going to use ETABS. ETABS is the short form of the extended three-dimensional analysis of building systems. We are going to use this one, and of course, we are going to use the Excel to help us to minimize time. So we are going to manage time through this. So now, after opening AutoCAD, of course, we have to prepare the architectural layout from the architectural plan. And I shared the architectural layout that we are going to use. It's just a very simple plan just to help us understand how to prepare the structural layout, and how to perform design in AutoCAD, in ETABS and prota structure. So in the structural layout, this is what we're going to do. From the architectural plan, you have to create the grid lines using AutoCAD line command. So for this one, first of all, as we open AutoCAD, I just saved. I just set my units. I think this one you also. Then the next thing is now to create the layers. So we are going to create the following layers, and we are going to follow these settings, because these settings are the ones that I have been relying on to create some some layouts which are nice looking and structurally accepted. So the first layer, we are going to create the grid line. We are going also to create the beam layer, the column layer, the bubbles, and I'll explain what is this, the text, and also the dimension and the layer for the staircase. So to do this, I'm going to screenshot this and copy paste it to AutoCAD, at least for us to see it well. Okay, where is it? Okay, copy, Control C. Then I'll paste it to AutoCAD, Control V, somewhere here. So in this AutoCAD, we are going to create the grid line layer. So to create these layers, it's very simple. It's very simple. I'll just move this one somewhere here. Now, you come here to layer properties, under home. You come here to layer properties, then this window will pop up. So we have these four icons. The first icon is to create new layers, this one. Then the second one is to freeze or to unfreeze. I will show you how to use this one. Then this one is to delete any layer created by mistake, or if you don't want some layers, you can just delete the layers using this icon. But for our case, we want to create these layers. So okay. So to create the layers, I'll just press this icon. New layer will be created. So this layer, just name it grid line, like that. Then as you can see, we are going to give it a red color with the line weight of 0. So for the color here, we'll just give it red, like that. Then for the line weight, I'll show you how to set this. Then I'm going to create another layer, beams. Then we'll give it the yellow color, but you can just use any color. This is what I like. Then we are going to create the layer for columns. We'll give it the green color, as you can see from this pic. Then we are also going to create the layer for the bubbles. I'll explain what is this, and you'll also see it in ETABS. So for this one, I'll use the magenta color. This is the magenta color, this one. This is the magenta color, as you can see. Magenta color. And then we also have to create the layer for the text. So this one, I think we can use the white color, just the normal white. So we have this white color, and then we have this one. So we are going to use color 255, because this white color, when you now export this thing to your model or your layout to the layout, this color, the white color, will not be visible. So it's good to use the white color, but color 255, like that. Then after that, we also have to create the layer for dimensions. We are just creating the layers, and we are going to use them. So for dimensions, we are going to use color 30, but you can actually use any other color. So color 30 is here, this one is color 30, but you can use any color. Then we are also going to create for text. For the text, we are going to use color 8. So I don't know, color 8 should be somewhere, but you can just type here color 8, then press OK. So that is color 8. When you come to this icon, color 8 is here, and then this is 9. This one is 7. So for this one, you can just use color 8, like that. So that is all. After creating the layers, of course, we have to get to put these properties. So to enter the property of each layer, we will first of all select, we'll make each layer as the default layer. We'll start the layer, this one, grid line. Then to set the line weight of this layer, you just have to open the settings of this layer. So to do that, you can right click, then come here to settings. Where is settings? Okay, if you don't get the settings, there is a shortcut for that. You can come here to properties. you have to look for properties after right clicking, but as you can see, we don't have that option. So what we can just do, you can come here to properties, this one. After making that layer as your default layer, click this, then this icon or this window will come. So the layer is actually grid line. As you can see, the default layer is grid line. So you have to do some settings. So for this one, line type is, of course, we are going to use a continuous line type, or we can just use by layer, but it's good to use the continuous line type. For the grid line, I will tell you the reason. Of course, we have to use the dotted line, but for this one, we are going to use a full line. I'll tell you the reason. Then the line weight. This is so important. The line weight, we are going to use line weight 0, this one. Then you can just close this window. After that, we'll turn on beams. We'll make this one our default layer. We'll go back to these properties, but I dislike using this. So what you can do after making this layer as default, as current layer, you just press Control 1. So Control 1 and the property of that will come. So make this one to be the line weight for the beams. You can make it 18, as you can see. So 0.018 like that. Then close this window and then turn on the columns like that, Control 1. Then for the columns, you can use 20 or 18, but for this one, I'll use 20. Then after that, you can also turn on the bubbles. So for the bubbles, we will use 0, Control 1. Then we'll just put 0 here for the bubbles. Then we have the text dimension and the staircase. So for the text, we also use 0. As you can see, 0. This one is okay. Then for the dimensions, 0. So as you can see, if 0 is your default, if 0 is your default line weight, then it will be assigned to all the layers that are below the layers. So are below the current layer. So we are just going to stop at that point, and I'll just delete this one like that. Now, the next thing after creating the layers, so we have to start understanding now the architectural plan. So from the architectural plan, we will now create the grid lines using the AutoCAD command line command. Now, for this one, first of all, I'll open the plan that I just shared with us. It's also a picture. And for us to use this picture well, I'm going to screenshot it like this. Then our screenshot is somewhere here. This one. Okay. I'll dismiss this. Okay. Let me screenshot again. So, I will screenshot again. I don't know what's the problem with my screenshot. This one. Okay. Okay, it's here. I think, okay, it's here. So I'll Control C and Control V here, like that. Now, I want us to understand this architecture right now. The first thing, as a structural engineer, remember, we have the architects who are supposed to prepare the plans for us. So you have to take the plan from the architect and then understand what the architect is trying to come up with. The first thing is to understand the type of structure, because from that is when you'll understand you'll understand how to assign the loads, especially the live loads. Now, for this one, as you can see, we have the bedroom. We have one bedroom here. We have another one here, and then we have another bedroom here. So we can just treat this one as the master bedroom. Then we have the porch here. I think this one is just for relaxation. Then we have the garage area at this point. We have the utility area here. We have the kitchen. Then this one is the dining and the living area. And of course, we have the staircase here. So we have the dining hall here. Now, from this small architectural plan, as you can see, it sounds like a very small building, but when you check the dimensions, actually this one is 11.5 and 11.5 by 11 meters. It's almost a square. So, what are we supposed to do from this architectural plan as engineers? First of all, from the layers that we just created, from these layers, you have to figure out where to place the grid line, where to place the beams. And remember, we have two types of beams. We have primary beams. These are beams which are connected from column to column. These are a beam connected to supports. We have secondary beams, which are now beams connected to other beams. That is the basic knowledge that we know, primary and secondary beams. Then you also have to figure out, now this is important, where to place the columns, because you cannot, as you can see from this architectural plan, actually we don't have columns. It is now the discretion of the engineer to decide where to put the columns. So as the engineer, where are we going to put these columns? So we will decide that one in a few. Then of course we will have to put the dimensions, and of course the staircase. Now, from this architectural plan, where are we going to put the grid lines? Of course, from this plan, as you can see, we have the grid lines, and the grid lines in X direction and the grid lines in Y direction. Now, in X direction, you can take these grid lines from the architectural plan as they are, or you can try to alter them a bit. So the first thing in AutoCAD, without even understanding this architectural plan in detail, the first thing to do is to create the X and Y lines. So you have to put this line and this line in X and Y direction. So I'll just do that. Let me just delete this one. You can just be using the picture itself. Now I'll create this one, and the first thing is to turn on the layer, the grid line layer. Sorry for that. Turn this line on. Then I'll draw this line, the perpendicular line, in Y direction like that. So I'll just make sure my ortho is on, orthogonal. Make sure it is on. Then draw this line. Then of course draw this line also. Now from these two lines, we can now come up with the other grid lines. The assumption here is we have now this grid line 7 according to the architect. Then we also have grid line A. Now in X direction, let us create the other grid lines. Now, as you can see from this part, at this point where my cursor is, we have the bedroom. Then at the below it, we have the bathroom. We have the staircase. Then we have another bedroom. So this is the first part from one grid to another grid. So what are we supposed to do here? From this grid, all extra grids, we must put the beams and columns at that point. That's why we must have this grid. We must have this grid. The bottom grid, we will have it. Of course, this grid in the western side, in the eastern side, we will also have this grid line, and we'll also put the beams at that point. Now, as you can see from grid line A, we have that 400 millimeters to grid line B. But as you can see to grid line B, this grid line B is only giving us this wall at this door to the bathroom. But as engineers, as we are going to assign the loads, we always have different types of load. We have dead load and live load. Some of the dead loads, we have 4 types of dead loads. We have self weight of the element. If it's a beam, we have the self weight. Then we have other loads like partitions. have services and finishes. So some of things like that we have to figure out. So for this beam or for this wall, this one, because it's just going to allow entrance into the bathroom, this one we can just treat it as a partition wall, so we don't have to include it in our structural layout. So this grid line B, in short, we have to leave it out. We don't have to include it in our structural layout. So we are going to create grid line A, then we will do away with grid line B, then we will create grid line C. Why C? Because as you can see, from this beam or from this grid to grid line C, first of all, the span is now growing. It has now shifted from 34. If you sum up this one will be 4600. So actually we can now take this one because it's good to have shorter spans. The good be practice. Don't use longer spans like 6 meters and above, because if you do that, then you'll have to overperform the checks. Apart from deflection checks, you'll have to perform some other extra checks. We will discuss that one when we go to BSET 110. Table 3.9, we'll discuss that one later. So let us agree that from grid line A, we are going to create grid line C. So how are we going to create this grid? So this one is 4600. What we are going to do, we are going to use this line, then offset it and get the 4600 at this point. So as I just said, you just have to offset this line. So you just tap O for offset, and then you'll get the offset here. Of course, we have this command at the top here. We have the rotate, we have trim, and so on. All these commands are here. Offset is here. But now, if you know what you're supposed to do, just type, then AutoCAD will give you the shortcut command. So I'll just type offset. Then we are going to use the millimeter units. So for 600, then enter. So this thing, we can offset it in the negative direction of X or in the positive direction of X. And because we created this line as our grid line A, and we are moving in the X direction, we just create this one as our first line. Then after creating this grid line, immediately we have grid line D. So we can go away with the grid line D, but now let's figure out from grid line D to grid line E. When we sum up this one will give you 69. So 69 is too big because we are also trying to play around with the deflection. We don't have to allow our beam to over deflect. So how do you avoid that? You have to introduce some support in between your beam. So for this one, we are just going to come up with another column here at this point, then we'll introduce another column here. So we are going to offset from grid line C to D, that is 34, then to E, we'll introduce 35 millimeters. So to do that, offset command is still on, but if it disappears, you can just type offset again like this. So this one is 34 and 35. So I'll just type that 400 here and then press enter, that 400. Then because the offset command is still on, you just press this line, and it will now allow you to enter the other dimension, which is that 500. I think that is okay. Then this line, as you can see, this is just an extension. You can do away with it. So we have to trim this. To trim this, you'll use your scissors at this point, this one. Use that command, then just trim. Now, this one, we have the grids in X direction. As you can see, they are now flowing in X direction. But now we have to come up with the grids in Y direction. But this one we are going to create them from top, and we come in the Y negative direction. So how do we do that? First of all, we have to understand where to put our main beams. As remember, these grid lines will now tell the structural engineer that now these grid lines, this is where we are going to put the beams. So this first grid line will just be there because it's there. It will give us the external beam. Then at this grid line 6, do we really need a beam at this point? This one is 3 meters. The first thing is to observe the span. You have to observe the span. Then we have some other parameters that I will share with you the link, and actually you'll have to read more about that. Now for this one, we have this grid line 6. If we allow this beam to run to this point from grid line A to E all the way, then it will have to cross we have the dining room here, then of course we have the living room here. But now, is this beam going to affect anything at this point? Of course, it's not going to affect. We can just allow it, and the bottom and the top will now figure out if we can introduce a column or not, but I mean the walls or not. But we just allow for structural stability. We are going to allow this beam to just run from this point to the end here. So this span is 3,000. So to do this, we'll just offset this by 3,000 downwards like this. Then after that, we'll also figure out from this grid line now, from the 3,000, this beam now, are we going to have this grid line 5? Now, you have to figure out this distance. The span is just 2,000 millimeters. That is 2 meters for the bathroom. Of course, we can do away with one of the beams here. But now, is it going to affect anything to our structural building or not? For this one, because we have the staircase here, and the intention of that here, this, because we have this staircase, then architect want to support this staircase to a beam here, then to this beam, and of course to support it at the end here. So what we are going to do, we are just going to follow what the architect tried to intend at this point. So the intentions of the architect must be followed. So for this one, with the grid line 5, we just allow it to run. This beam will just allow it. Then of course, we have this grid line 4 will also allow it to run, and so on. So for this one, we have 2 meters, then 2,500 millimeters. So the offset command is still on. We'll just press it. Then this one is 2,000, 2 meters. Then we have the 2,500 millimeters for the staircase. For the staircase. Then after that, now we have the 3,500. We have this 3,500, but we will discuss, because at this point we don't have a slab at that point. So we have to make sure we come up with something that we eliminate this point. We don't have a slab at this point. So this 3,500 we will first of all include it. So to do that, we'll just offset it on by 3,500. 3,500. Then we'll trim this extents like this. Now, after trimming this, now let's figure out how to do away with this. As you can see from this other end, from grid line 1 to grid line 2, where we have now the window for the living room, this is 1 meter. So you just have to offset this beam up by 1 meter, and then we'll just trim. So how do you go about it? I'll type offset, then 1 meter, that's 1,000 millimeters. Then offset it upwards like that. But we don't have this beam and this one, and of course we have to trim this one. So to do this, you just pick your trimmer, your scissor, then trim this, and this one. As you can see right now, we have our model, our layout resembling this. So the next thing after creating your structural layout, I was preparing this, of course. After we have to consider the position of the main beams, that is the primary beams. Secondary beams, you can just introduce them if you feel like the span is so big to go beyond the deflection limit. Then from this layout, now that we have the layout, we have to come up with the beams. So how do we introduce the beams? First of all, I will turn on the beam layer. I'll turn on the beam layer like that. So from this beam layer, we're going to create the beams from these lines. How do we do that? Now, first of all, you have to know the size of the beam. You have to perform the precising of the beam. We are not going to talk about that one today, because for the beams, if you perform the precising, we have 2 ways of performing the precising of the members, of precising the members. The first way is deflection. You have to use deflection criteria. I think I have discussed that one with some of us, but I will have another session that just to discuss that with all of us. Now, for beams, if we follow deflection, we will get some of the beams will be too small. So we are not going to use deflection. At this point, you just have to use the engineering experience, the engineer's experience. So most of us, we don't have that experience. I know most of us, we don't have that experience to tell that let's use a beam of this and by this. So what are we going to do? we are going to use other engineers' experience and figure out and come up with what they have been using. So in that, we are going to use the commonly used beams in the field. And what are these commonly beams used in the beams? The smallest beams in Kenya is 200 by 450 millimeters. That is the smallest normal beam. Otherwise, you can use 200 by 300 millimeters for the length beam, that is ground beams, mostly 200 by 300. But for the normal beams, for the normal structural beams, we've been using 200 by 450. So if that beam fails, then you'll have to increase the depth. You can use 200 by 500, 200 by 600, something like that. But now there is a limit. I'll take you to class 3, 12, 11, 2 of BSET 110. It will tell us some limits. So for this one, but now you have to figure out in Tanzania, just figure out from your experience, from your professional engineers, what are the most commonly used beams. You will get that one. So if it is 200 by 450, go with it. The other day I discussed with one of us from Zimbabwe. They have been using, and in Nigeria, they always use 230 by 450. 230 by 450. So let's figure out that one. I'm telling you this because if you perform the deflection, if you go with the deflection criteria, actually you will end up getting 200 by something like 200 by 196. Like the depth will be too small. So just go with what is in the field right now. So for this building, we are going to use a beam of 200 by 450 millimeters. So 200 by 450 millimeters, this is what I mean. If this one is our beam, we have three types of beams. We have the rectangular beam, then we have the T-beam. So I'm going to create something like this. Then I will copy this here, then another one here. So I'm going to move this one. Okay, I'll have to turn all this on, the snaps. You have to turn all this on apart from the last three, because this last three will just use the assumptions. We'll just use this one like that. So I'll just use this one and drop it here. So this beam, this is a T-beam. I'll discuss with you. I think I discussed with this one with most of us, but I can also discuss it with I can rediscuss it with us. Now this one is the L beam, and of course the first one, this one is now the rectangular beam. So this depth, this is what I have been saying. So this one, this distance, I don't know if it will be visible. I'll just control 1 to change the dimensions. Of course, for this one, I can just use 300 to make it visible like that. So this is the width. This is the width of the beam. This bottom. This is now what we call the width of the beam, or the B web. B web. We will discuss this one. Then height of the beam is from the top here to the bottom. This is now the height of the beam. So the distance from the top to the bottom, the height, is what we are now referring to for 450. And most of the countries have actually adopted that one as the initial height of the beam. But for the beam, mostly we always want our beams to flush with the wall thickness. So if your wall thickness is 200, we always go with 200 millimeters. Nigerians and some of the countries are using 230 because most of their wall thickness is they always use 230 millimeters. So because we always want the flush of the beam and the walls to be there, that's why we do that. So we will use 200 millimeter as the thickness, as the width of the beam. Then the height will actually use 450. Just remember that, because as you go to the two softwares, ETABS and the prota, that's what we are going to do. So after turning this layer on, the first thing we are going to offset, because right now we know very well that the beam that we're going to use, the thickness is 200. So you just have to offset these lines up and down, left and right, and get the 200. So I will start by this one. So I will offset. If the thickness of the entire beam is 200, then of course you have to offset from the center of that beam. You have to offset up by 100, down by 100. So that's what I'm going to do. I'll just offset up, then down like that. This one left and right, like this, for all the beams. Sorry. Now, as you can see, now that's a mistake actually. Let me share with you something here. I think I have it. Copy. I'm just copying something, and I want to drop it to our Telegram group for us to have it. Now, I'll continue, but okay. Okay, we have this one, AutoCAD, copy, Control C, and then I will drop it to disk D first. I think this is good. Now, inside AutoCAD, we have a command, this one, the double offset. I always like using this one, especially if you get a very complex building, then you'll have to use this command to help you. So for this one, I'm going to undo like this. Now, how do you use, of course, I'm going to send you the command for free. How do you use this command to do what we want to achieve? You'll come here to manage, then load application, manage, then load application, manage, load application. Then you'll have to zoom into the folder containing the application, the double offset command. So to do that, you'll just come to this directory, then go to disk. Mine is in disk D. So I'll just go to this PC, disk D, AutoCAD, then 2024. Then we have break all and the double offset, the DOF. So I'll just load the application, always load like that. Then I'll just close. Okay, just a second. Okay. Now, after loading the application, remember the icon name is DOF, D-O double F. So this D-O double F is the command that you are going to type here. So I just type DOF, D-O double F, like that, and then press enter. So it will ask you for the offset distance. Of course, I'll enter 100 millimeters like that. So this one is good. When you press, it will just double offset. If the command disappears, you don't have to type DOF again. You just have to use your spacebar. You have you have to use the spacebar on your keyboard, then it will just be picked. You press it twice like that, then you continue. For any command, to pick the previous command, you just have to press the spacebar like that, like this. Then after this, we now have to change this, because these ones, all these lines are inside the grid line command. So you have to select all of them and now drag and drop them into the beam, into the beam layer. So what I'll do, I'll just select the two of them like that, then drop them inside like that. Another way you can you can turn this layer on, draw one of the line outside here like this one. Then what you'll now do, try to use the match properties, then come to this line, then pick, it will ask you to select the source object. So the source object is the line that is now related to the current layer, beam layer. After that, it will now ask you to select the destination layer. So the destination layer is this outer offset lines, these ones. So I'll just select them like that, then I think we are done. I think this is okay. This is okay. Up to that, I think we are now good to go. Then, what is the next thing to do? You have to trim the extents. You have to trim the extents. So I think I wrote this one down, but you have to double offset. You have to select the external or the offset lines and drop them into the beam layer, or you have to draw a beam line and use the match command to change the properties. I think that is what I have actually done. You just have to draw a small line outside, then use the match command, match properties, then do the right thing. So after this, you have to trim the extent. So I'll just trim this extent. So to use the trimmer, you just have to come here to your scissor, the trimmer, then trim this extent. As you can see, we don't have this because we just want a perfect alignment of the beams and what? A perfect alignment of the beams, of course. As you can see, I'm just trimming the extent. So actually, this is the reason why I used a small and simple plan. But a good practice is for you now to search for some complex plans and try to do the same thing. Then in ETABS and in prota, it will be so simple because we are going there right now. So, okay, I'm almost done with this. Now, after this, you have to make sure that this the corners, you have to make sure that they meet at 90 degrees. So how do we do this? You can of course use this one, drag and bring at this point. Then you have to extend this one here. But this one now will take much of your time. So to do the shortcut, you have to use the chamfer command, chamfer. So chamfer under fillet, we have this drop down. This one, you have to come here. We have the blend curves and the chamfer. So this one is mostly used while designing the roads, the blend curves in Civil 3D. So we'll discuss this one while doing the Civil 3D. But for the chamfer, this one will help us to make these two ends meet. So to do this, you just have to select the two corners. You have to pick the same command using the spacebar, like this. Pick the spacebar, click the spacebar again, press again, very fast. Come here, press the spacebar again, like that. So I think up to that point we are okay. If you have any question, please just drop it to the chat box. Then immediately after this, we'll discuss it. Now, the layout is almost complete. After this, well, of course, we have to come up with what? The dimensions. So how do we come up with these dimensions? First of all, we have to put our bubbles at 2 meters from the main layout. So the bubbles will be somewhere here at 2 meters. So how do we get these 2 meters? Just type offset, then 2 meters, 2,000 millimeters, like this. Then I will use this external line. I'll offset it outside. I'll also use this one, then offset it outside. Then we have to extend this we have to extend these grid lines to touch these two lines. Then we'll delete these two lines. But before we do this, because as I said, we are going to use two softwares, so there is a criteria on how to go about all this. So what I'm going to do, I'm going to save as. So to save as, you just have to Control S. I mean, you have to press Control Shift S. Then this one will come to give you a way of saving us. So for this one, I'm going to save it prota, like this. Then I'm also going to save as again, Control Shift S. Then I'll call this one ETABS, like this, like that. So we have three models here. We have the model that will be used for ETABS, then the model that will be used in ETABS. Now, we will start with the model that we are going to use in prota. So to do that, I'll just go here to at the start. As you can see, we have all of them. We have the layout, the one that we created initially. Then we have this one for prota. I'll just open it. Then we have this one for ETABS. So we will start by this one for prota. So for prota, I'll now offset by 2,000. We'll just continue 2,000. Then we have to extend and come up with the grid lines, the bubbles at this point. So to extend, you just have to type E for extend, like this. Then extend these lines. Okay, before you extend, you have to select these two lines because we have to extend them to touch this line. So I'll now type extend, like that. Select this. Select this. Then lastly, select this. Then for this one, for this line, you have to select this. You have to select these lines like that, like this. Then for this one, we have this. Then we have this. Then we also, oh, okay, this one will be used for this. Now, after this, I can now delete this. So we have to come up with the bubbles, and from this, as you can see now, we have to create the bubbles of say 280 millimeters diameter, and also place them at 2 meters from the external beams. So these 2 meters we have already created this. So you just have to create the bubbles. So for this one, to create the bubbles, you first of all have to turn this layer on, the layer for the bubbles. Bubbles, these are those small circles. Those small circles. So you just have to come here to the circle. Then we can just use this one. You don't have to be so accurate to according to what I said. So I just type move. Then I'll touch this point and move it here. And this text we will just have to turn on the text layer on like that. Then the text command is here. Come here, we have the multi-line text, then we have the single text. So for this one, we are going to use the single text because it's just a one-letter text. So this one will just come inside here, then type letter A like that, then press out. Then I'll just move and make sure it is inside like that. We can just use that to one, this one, somewhere like that. Then we have to populate this to all the grids. Then after that, we will now rename them. So I'll just copy. I will type C for copy. Then that is A, that is A, that is A. Then as you can see now, we have A. This one will be B. Just have to make sure that your caps lock is on. Then this one is B. Then this one is C. Then this one is D, like this. Then you have to copy this one and populate them. Populate this bubble and the text to these other grids. So how are we going to copy this one? You cannot copy it using the bottom. You have to copy it using this side because you are going to drop them at this side. So to do this, you'll just type copy, see. Then you'll copy this point. Then orthogonal. Now you drop them like this at these points, like this. Then, as you can see now in X and Y direction, X is like we are going to this direction, then Y, we are going up. So the naming of our grids, we have to name them A, B, C, D in X direction, towards X positive direction. Then for the Y direction, we have to name them from bottom upward. So for this one, because this one is the alpha naming, then this one will just use the numerical names. So for this one, we just use 1. Sorry, this one is 2. Then this one is 3. This one is 4. This one is 5. Then lastly, this one is 6. Now, after doing this, so the next thing, remember we are creating the layout. The next thing is now to come up with what? The dimensions, because we have to actually see the dimensions of this structure. So to do this, we'll just turn on the dimension layer on like this. Now, pay attention to this because this one is very important, especially for those of us that we are meeting for the first time or we are creating the layout for the first time. So after turning this layer on, we have to do some settings for the dimensions. And as you can see, I'll open another document which I think I shared with some of us. Okay, desktop. Okay, online. The structural, I think it's this one. Okay. Now, for this document, don't know what's wrong. I can't even carry it. Why? Okay. Okay. I wanted it to be here, like that, like this. So this one is the structural layout. Now, as you can see for the structural layout, the first thing is to create the structural layout. For the structural design, you have to select to create the structural layout, and all the layers and the weights are here. Then now we are here. Let me see. Can do this. Now, to create the center line, we've already done that. Create the dimensions for the plan. So this is the best thing happen at this point. So have to the lines for the beams by 2000. I think we've already done this. Then we have to extend the center line of the outer offset. I think this one is okay. Okay. I just want two dimensions. Now, to set the dimensions, this is the procedure. This one is very important. First of all, we'll go to annotate, then do all these settings. But now, I want to us to pay attention for this, for the color. Okay, let's go there because I know what we are doing. So after this, after turning this layer as your current layer, the next thing is now to come the annotate. This is where you'll do all the important settings for the text and all other things. So the first thing is to set the text, to come up with the text for the dimensions. So what are you going to do? You create a new text style, and this one just going to name it dimensions dm, like this. The next thing for this dimension, you have to select the type of dimension that you like to use. So for this one, I think I'll use the monotype. The monotype. I use the monotype. I'll come here, then monotype. The bad things that where is monotype? This one, Cosiva monotype. Cosiva, we'll just use this one. I like this one. I don't know why, but we'll just use this one. Then we'll just make it current. Yes, then close. So after doing that, that's the first setting. You just come here, do your settings. Of course, it's not compulsory, but it's just a good practice. But if you don't do it at this point, you'll have to do it at this point. After setting the setting for the text, you'll come here to dimension, then click this arrow. Now we are going to create, by default, we have three styles, the annotative, the ISO, then we have the standard, but we are not going to use this one. So I'm going to create a new style, we're starting with the annotate. So this style, I'll just name it general dimension, something like that, then I'll continue. So after this, we have some settings. So we have to go through all these settings and come up with a nice looking style. So for the lines, we are going to allow it to be by the color for the lines. We can just use a white color. Then, but that is by block. Then the line type will just leave everything as they are here. But now under suppress, this one is very important. This line extends. So we'll just suppress them like this, or I don't like suppressing them because you'll make them, all of them will disappear. So instead of doing this, you just turn them on. Then at this point, you can use 25 millimeters. You'll just see how they will appear, 25 millimeters. Then for the fixed, here, you can also use 25 millimeters or 20. You can just use any. It's not compulsory to master this. Or let's use 10. Then after that, 10, oh, sorry, this one is 10. Then for the symbols and arrows, so here you can pay some attention. For the first arrow, these arrows, I always like, so here you select what you like, what pleases you. So for this one, I'll just use closed blank. Here also I'll use closed blank. Then for the arrow size, I'll use 150 millimeters. Then for the center marks, for example, if you have a circle, then if you draw this, if you put this diameter of the radius, then you'll have to see some center mark here. I don't like using this, so I'll just put none. Then under the arc length, you can put them to be above the dimension text. Now, here we are good to go. Now, text. Under text, this one is important. Remember, we did our text. We've just done our text. We created our text style, the dim. Otherwise, as I said, if you don't do the settings at this point, you can of course do them using these three dots. You just if you click here, you can now come to the text and do the text settings. But otherwise, this one is okay. For the text color, we'll just allow the text color to be by layer, or let the text color be by layer. Now, text height, this one we're going to use 320. We are going to use 320 like that. Then under the text placement will just make them to be above. As you can see, this one is okay. Then the horizontal, for the horizontal, we'll just make them to be aligned. Now, this one is important, the offset, the distance between this line and the text. The distance between the line and the text, this one will use 75 millimeters. You can be using 75 or 90 millimeters, but you have to monitor them and see. Then for the text alignment, we'll make them horizontal with dimension. As you can see, if you put them horizontal, this is what you'll see, which is not good. So we'll just use horizontal or aligned with the dimension line. Then under fit, there is nothing here to change. This one is important for the primary units. As you can see, we have some decimal points. We don't want these decimal points because from our dimensions, there's actually the precision is just 0. So for this one, for the precision, put 0. Now, what other setting? For the alternate set units, there's nothing here to change. As you can see, it's frozen. Then for the tolerances, everything is just good. What I want to do, I want just to change this text, the line color. I don't want light. For the color, I can use green. I think this one is okay for me. Then you can now set this one and make it current like that, then close. So after this, while in annotate, you can now start putting our dimensions. So how do we do that? Come here to the linear dimension. Of course, it will ask you if you are sure that you want to use a scale of 1:1. That's okay. We'll just go with that. Then we'll click OK. So we'll put the first dimension. We can turn on the author. Then put our dimension somewhere here. So this is our dimension. So we have to put all the dimension all through, but now it's good to just continue to allow AutoCAD to pick the dimension as we continue. So I'll just use the continue command, this one, continue the command. So I'll just click here, and then lastly, I'll click at that point. So this is okay. As you can see, this one is 46, 34, 35, and that's what we had. 34 plus 12, that is 46. This one is 35. Then for these other ones, for the vertical ones, we just do the same thing. We'll come here to the linear dimension. Then we'll start by putting the dimensions here, like that. So as you can see, this one is not coming to the center. What you can select this one and change its text height to 300 and see if it will work. Remember, we used 320. So okay, to turn on this the property of anything, you just press Ctrl+1 AutoCAD. I think this one is okay. It's now working. Then we will continue. So I'll just do the same. So the text height for this one is 300. What I'm going to do, because I want the uniform text height, because if I click this one and come to the properties here, as you can see, the text height is 300. So I want uniformity. For the uniformity, you can just come here, properties, then match properties. Match properties, and then pick this one as the source, then pick this one as the destination. But this one is not the right way. The right way is now to go back to the dimension style here. Double click on this one, or you can just come here to modify. Then for the text, change this one to 300 to change the entire layer. Then you can set it current, then close. So this one is 300, as you can see. After doing all these settings, so we have now a very bigger task that we're supposed to do. This task is very big and it's very tiresome. And I'm not going to allow it to take much of our time, but make sure you understand something. So, okay, we have to do the sizing of the columns because you cannot carry the unsized columns to the softwares. So how do we perform the column sizing? So we are going to use Excel because as you can see from this PPT, we just said we are going to use MS Excel to help us some that's after the meeting, upon request, of course. So we are going to do the precising of columns. Each joint we are going to put the columns. So to put the columns, I'm going to open the Excel. Okay. Okay. I think this is okay. So I want us to understand how to use, because I think most of us have this Excel, but now, do you know how to use it? That's a big question. Please make sure you understand how to use the Excel, then it will help somewhere. Let it open. think I'm still on right. Now, let's continue. So, this Excel will give you a welcoming message. It will recognize you. It will tell you to welcome to the world of structural engineering, where design is what we like. Now, so the first thing, the Excel has several types. We have the home slab design according to BS 110. Of course, it does Eurocode and BS. So under home here is where you can change the design code. Of course, you can pick the BS 110 or a Eurocode too under this drop down. But I don't want to go into that. And then you also have to set the density of concrete here. So for this project, we are going to use density of concrete as 24. Of course, we can change to 25 or whatever. As much as you know the density of concrete, you can just change. But for this one, we are going to use 24 kilonewtons per meter cubic. Then the type of structure that we are designing, is it a structure with a roof slab or a structure with a roof? Because this one will help us to understand how to assign the loads on the roof. We have a roof with access and roof without access. We are going to discuss all those in in BS 6399 part 1. So for this building, for this plan, we will just assume it's a 4-story building with a roof slab, and this roof slab will have water tanks to supply water to these people, because now they must have access to water. So we are going to allow it to have a roof slab. Then of course we can select a structure with a roof, but this one we are going to use the roof slab, and we'll discuss some more things at this point. Then you can do the slab design and get the output calculations. As you can see, you can print this one to PDF and get the output calculations, but we are not going to do this one today. You can also design the beams and get the detailed design. As you can see, the detailed output, you can print this one. You can also perform the shear design, the links, the stirrups. You can do this. Now, our interest here is to perform the column sizing. So let us discuss this one. So for the column sizing, first of all, I'll turn the AutoCAD on. Let me close this one for ETABS. Let's concentrate. I'll just concentrate with prota first, because for the ETABS, we will have to do some other things. Now, for this one, what is the procedure for performing the column sizing? The first thing to do is for us to know the size of the slab. That's the first thing, to know the size of the slabs. So how do we know the size of the slab? We have two ways. The first way is through engineering experience. I think I discussed that one with you while performing while putting the beam dimensions. The engineering experience. So for this one, that's why as an engineer, you have to have someone who can guide you as an engineer. Like for me, I have my senior actually guiding me. Here we go like this, we do this, then you'll be a professional engineer, or you'll be a consulting engineer at a faster rate. So you must have someone to guide you. I think that's well noted. So through that, because for this building, through pre-design, you can end up getting a slab of, for example, 175. But that is totally uneconomical for someone outside here. So an engineer will just tell you, please use 150 millimeters. Now, is 150 going to serve? That's now a question for you as a designer. So I don't know. We are going to do the pre-design for this building very fast. Though time is running, we've already used 1 hour and 4 minutes, seconds. I mean, minutes. So for this building, we are going to do the pre-design very fast. How do we do that? The first thing, let me just have this text, and please, kama haujatendi class yangu before, use this one as an opportunity to understand how slab pre-design is done. So the first thing, we always use deflection criteria. And what is deflection criteria trying to tell us? Here we have to get the span, the shortest span of each panel, the shortest span of each panel. So we are going to select the shortest span of each panel. For this panel, panel A, for example, we have 3,000 and 4,600. So we have LOI and LX. LOI is the longer side and LX is the shorter side. So you have to get the LX of each panel. And how to do that? You just do it by looking, by observing. So for this one is this 4,600 and this one is 3,000. So I'll just change this one to 3,000 because this one is a shorter side. Then I'll copy this and populate it to these ones like this. And of course, I'll just do away with this. I'll populate to all panels so that we can do this one very fast. Now, let's continue. For this second panel, we are comparing 34 and 3. You'll find out that 3 is the smaller side. 35 and 3 is the smaller side, that's okay. For this panel, we are comparing, but now we have to monitor where we have the staircase. So for this one, sorry, we can just close this one. Good. So for this one, the staircase is at the third panel from top. So we'll just do this, then we'll come here. So this one here is where we have the staircase. So we have two types of staircase. Let's discuss staircase a bit before we continue. We have a staircase which are monolithically constructed with the structure. What does that one mean? This one means as construction is being done, at the same time you are doing the construction of the staircase at the same time. But we have staircases which are non-monolithic. This means you will construct them later. So what does this one mean? You can also perform the design of the design. You can perform the design and everything of the structure and do the design of the staircase later, because if the contractor is not going to do the construction of the staircase at the stage where the building is being constructed, why do you perform you can perform analysis and design later? I think that one is noted. You have monolithic and non-monolithic. Monolithic, this is done. You have to perform this design together as you perform the design of the other elements. Non-monolithic, you can just leave the staircase and do it later because it will be needed later for construction. So for this one, we'll assume non-monolithic. So I'll just do this, an X to show that. If you see an X to any structural drawing, it will mean either it's an empty space or it's an open to sky space, or it's a place where we have a ramp or we have a staircase, something like that. So you have to monitor that, or it's a space left for the lifts, something like that. Avoid. So for this one, we'll just leave this one for the staircase. Now let's come to this point. We have 46 compared to 2000. So this one 2000 will win. This one is 2000. I'll just type 2 because of time, 2. Then here we'll just use 2 like that. That is 2000. Then for this one we are comparing 25 by 35. So this one is 25 because we are trying to compare 25 by 35 and 25 by 30. So 25 is the shorter span. For this panel, we have to understand what is this. So 1000 plus 25, that is 3500. We are comparing 3500 to 4600. So this one will be 3500. I'll just change this one to 3500. Then for this panel, we are comparing 25 to 35. So you'll find out that this one is 2500 because 25 is smaller. This 25 is LX because the LX is smaller side, the shorter side. Then for this panel, we are comparing, this one is 35. This one, 1000 plus this one, that is 3500. Then we are comparing it to 3500. So either way, we don't have the shorter or the longer. Shorter is equal to longer. So this one is 3500. Now, 35, sorry. 3500, something like this. So after highlighting all the shorter sides of each panel, so this is now the point. You have to select the biggest value or the longest length among all these highlighted white values. Which one is now the biggest? You have to select the biggest. So this one is 3, this one is 2, this one is 25, this one is 35, and this one is 25. So you'll find out that 35 is leading. But the problem is we have two 35s. Have this one and this one. So which 35 to select? Let me first of all delete these ones because they are not helping us right now. So among all these short spans, we have 235 as the longest spans. Now, as the longest spans. Now, which one is now? Which one are we going to use? we have this one. This panel is giving us 3500 by 3500, and this one is giving us 35 by 46. I know, without even telling, you'll just realize, apart from looking at the shorter span, now we'll look at the longer span. So for this one, we will use this one, this panel. We'll use this panel because this one is bigger than the 35. So we'll use this panel. We'll also delete this one. So at the end of the day, the span is 3500. So this span will have to go